Well, welcome everybody. It's a pleasure to be here with you on this Tekla Base Camp and exploring Estimodeling. We're going to do this in two stages. The first is going to be done by me representing Qnect and all of the ways we support the Estimodeling work. And then I'll turn it over to Ricky Horton, who's an expert and travels around the country helping fabricators with EPM and PowerFab. So it's a good duo. I'm Henry Letterman. I'm co-founder of Qnect. I've been in the business for 48 years, primarily detailing and doing connection engineering, and so happy to be here. So Estimodeling. Obviously, this is a very heightened interest with fabricators who traditionally have bid 10 to 15% of fitting material, 10 to 15% of the full tonnage to cover fitting material. And in today's competitive world, the ability to get more refined to measure the cost starts to become more interesting to firms, especially as other firms start doing it, often using the Qnect software. So let's start at the very beginning. The job I'm going to work with today is a project we did recently, Health Peak, and it's a mandated job, so the connections are predefined, but it's the same process, whether it's mandated or delegated. The same process for Qnect in that, well, slightly different process. We're mimicking the mandated connections, but with the delegated, we're actually designing each joint, optimizing each joint. We'll talk real briefly about it. So let's start at the beginning. With any job, we review the design drawings. So let me show you that. And here we go. So we might start just getting the parameters, because we need the parameters in a delegated design to make sure we get the right output based on the loads. In this particular case, as it's mandated, we want to see what the different criteria is for the mimicking of connections. But again, if we didn't have this information, just had the loads, we would engineer it directly. But the whole point here with the Estimodeling is to get the connections into the model, either mimicking mandated or designing them directly, right? That's the whole point. So we can capture the fitting material directly through PowerFab and then create more refined results to support the client. So then once we've gotten all of the parameters, the grade material, the LRFD versus ASD, the loading configuration, then Qnect sets those preferences up, those parameters on their website, right? So these are where all the parameters are set up. That becomes the conditions for design of the connection, or in this particular case, the mimicking of the connections to exactly match what the engineer is asking for, but again, capturing it in a model to transfer it then into a estimating software for this purpose. So we can optimize the joint. Double optimization is a fairly new addition for us, and it's pretty exciting, where if the beam is reinforced, we can needs to be reinforced due to a cope, we'll actually tell you what the next two beam sizes you can use in the same depth or one depth deeper, and that would eliminate a doubler. So that's pretty new, but you can well imagine connection types, whether you share plates as your first priority, you have all of these different choices, and for all of these framing conditions. You fill out forces, where it could be, in this case, mimicking joints, or it could be UDL factor on a table of loads, minimum job requirements, fabricator detailing preferences, cope clearances, minimum setbacks, dimension to the first hole, everything you need to detail the joints, bolted preferences. You've got bolts 1 bolt selection 1, bolt selection 2. We'll try 1 first, then try 2. Welds, all of the weld information, including the entire welding process. And Qnect will, based on all of this information, put the loads back into the model, put the welds back into model, put the symbol of the CJP or PJP at the tail of the weld, so that everything shows back in the model. Bolts, welds, cuts, copes, 100% of the joint itself is completed. Moment system, all of the moment clips, web connection, directly welded, etc. So just imagine you're designing the job, and in fact, on the welds, like I said before, let's see, and you've got the whole rat hole designation. So the parameters have been set up. They're complete. Qnect will work exactly within the range of these parameters. And then we go to the model where we're going to see the connections. So the Tekla model is created in Estimodeling. Loads are put into the model if we're delegated design, if the loads are on the design, but often they're UDL, which we do on the website. They're a table of loads we do on the website, and we're now able to run the connections. Generally, it's a very simple process. You get the app for Qnect 1, 2, and 3. And for this particular purpose with analytics and Estimodeling, we'll actually just grab the whole building like that. Then we, just hold 1 second, we'll get there in a minute. As we go black. So we'll grab the whole building. We will then hit button 1, Qnect, and submit it. Qnect will grab all the data, bring it up to the website. Sorry about that. Let's see. Yeah, here we go. Bring it up to the website. And engineer, organize the connections, the beam to column, flange column, web, embed plate, and then engineer each connections with the optimization tool. For each joint will be optimized. We're saving 2 to 4 bolts per ton, or 20 to 50% of the bolts. We're creating custom components from Qnect. Then we get an email that says it's ready. We then hit button 2, and then the whole file comes back down with 60 to 80% of the connected joints populating the model. So it's a pretty fast process. The most time this will take is a couple hours, even if it's 80,000 tons, which we have been used for. And then all of the connections are back in the model, as you can see here. If you click on the cone, that one's a macro, you'll get the engineering information, the capacity, and then you'll get all of the limit state engineering output, which, by the way, is accumulated as a package for the PE stamping. But the connection has all the welds, the cuts, the copes, so it's a complete section. It's ready for translation into an EPM file structure that would go right to PowerFab, and where the unit cost would be applied and then entered through the system. Codes can eventually be put into the model directly, and that will be for another discussion. So that is your process, right? Preferences based on design, build a model, Qnect the whole building, and get the information back into the EPM file, and Ricky Horton will go through that process. But we have one other opportunity here that we're excited to bring to you to really magnify the possibility during the Estimodeling process, and that's called analytics. And I want to walk you through analytics right now so you really get the sense of the power of the possibilities during the Estimodel to really maximize your competitive edge. So let's go to analytics, and we'll start with that. Analytics is important, significant early data, and for computational analysis support. So let's talk about what that looks like. Here's an example of a job we're helping a client bid. Engineer said fill the beam up, but designed for 66 skips, which we did. You can see that the efficiency is very poor, where the capacity is 159. So we moved the fill the beam up, and sure enough, we get an incredible connection. You can see on the optimized basis, this looks like about 4.5 inches. And ultimately, this connection actually is good for 90 kips. So that's a really pretty good response from the Qnect software. But, as a bidder, the best you can do is provide a credit deduct for time, cost, or both, because you don't really have permission. But let's expand the opportunity. Let's pretend let's start the analytic process here, because ultimately we're trying to find efficient joints for you to be able to consider and then use for your bidding process. So we say, well, look, there are two connections, double angles. Can we use one? And you can see, even as we add extra bolts, a single angle works, 3/4 inch bolts, and we still think it's cheaper. And then we try 1-inch bolts with a 1/2 inch angle, and we get an extraordinary efficient joint that's quite cheaper. And you might decide not to do this, but now you have options, right? You have options. So one connection can't decide and provide with enough data for a whole building. And so that's where the full power of analytics comes in. We start by running the building, optimizing every joint 9 different ways. We try different bolt sizes and grades, different framing conditions, single angle, double angle, and we create an output report like this. Again, this is in the delegated design situation as opposed to the mandated. But again, both we can create the data in a model for the Estimodeling, but with delegated design, we have a huge opportunity for optimization. Also, on mandated jobs, we're getting many engineers to override mandated conditions to give us the actual loads that we then use to optimize the joint. So that's changing. But just to understand this output, again, the dollar numbers are not quite relevant to most folks because the units will be different for you, but those numbers will be captured with the EPM file transfer into your estimating software. But baseline is what you said you were going to use. Then we try this arrangement, one bolt size, another bolt arrangement. You can see 1-inch A325 versus 1-inch A490, extended shed plate, double angles, welded, bolted, etc. Single angle down here. The standard bolts means we're using 3-inch spacing. The optimized bolts means we're varying the spacing from 3 to 6 in 1/2 inch increment and choosing the vertical spacing with the fewest number of bolts. That's been translating to 2 to 4 bolts per ton, as I mentioned, or 20 to 50% fewer bolts. 2 to 4 bolts per ton saved, or 20 to 50% fewer bolts. In this case, you can see we went from 36,000 bolts to 27. That's 9,000 bolt savings. But if we go to this one bolt size, we add another 10,000 bolts. So that's pretty extraordinary. 19,000 fewer bolts means 19,000 fewer bolts to purchase, 38,000 fewer holes to drill, 19,000 fewer bolts to install in the field, which can be extraordinarily expensive, and material savings implications. Now, any 2 or 3 of these can be downloaded into the model, and that information captured, transferred through the EPM file into PowerFab for more direct cost analysis for you and each unique user. The second thing that happens is the double plate reinforcement, where we will identify in this run with the delegated design the conditions where the copes of the beam are greater than the capacity of the beams with cope are less than the demand. And so we need to reinforce them, which we will, but we know that's expensive. So we give you the opportunity to understand which loads for each conditions work without reinforcing, so the engineer can decide on upsizing the beam or lowering the load. We've taken that a step further, as I point out in the early part of our video here. This is a job that had over 7,000 doublers. We created a map where they located them, and that also became a communication tool with the engineer of record. And we showed the beam. This is a UDL factor. This is what the demand was. This is what the capacity ended up being before reinforcing. So you'd want to sort of say, Mr. or Miss Engineer, is this work? Can you lower the load? But here's where we provided the two beam sizes that would eliminate that doubler. So pretty powerful stuff. If you're bidding, fundamentally, you at least will want to address with the GC either a condition that you didn't include them, or perhaps you'll help the GC be more effective in what's being asked of the bidders, which would be appreciated by the GC. The next thing that we do, which is provide all the specific joint information. Again, that goes right back into the model: plate thickness, well size, bolt lengths, 100% the information for each joint. The next thing we want to bring attention to is extended shear plate as an option in your analysis under the analytic process. Extended shear plates are particularly interesting, especially today with steel prices, for the following reasons. So extended shear plate beam to beam, first thing, no copes. That may not be as consequential to you, or it may be if you're doing them manually. But so we eliminate copes. The second thing that happens, because Qnect is so fast, you can actually build a model and run it within hours and order the material to the exact length. We did this on an Amazon project and saved 318 tons. For smaller projects, you'll see 5 tons to over hundreds of tons. And today, with the cost of steel, that could be significant over a year period of time with multiple jobs. And the third thing is that erectors tell us they can erect 30 to 40% more picks per day with the extended shear plate. And so now you have an opportunity to speak with your erector and work with them about what this would mean, how it would affect your competitive price. Again, we can download the job where we ran extended shear plates for beam to beam among the other preferences we use for beam to column, and then get your exact unit costs based on that material, bolts, welds, etc. So that sort of is this body of analytics where you can run this model 9 times, you can do all of this analysis, and then you can decide to download the information maybe 2 or 3 times for each of the different runs, trying to shear plate with a certain bolts, double angles, run it through the EPM, and facilitate your process. So that's what I wanted to present to you today. Qnect, integrating connection engineering, detailing, extraordinarily fast, that allows us to do so much so early, even in production, but certainly we're talking estimating, optimizing the joint. And then the umbrella of all of that is the analytic process that then can refine our work to efficiency, economics, and competitive advantage. And then, taking that data through the EPM file into the PowerFab software. So thank you very much for your time. With that, I'm going to turn it over to Ricky Horton to take it to the next stage so you can see the full integration through the end of the process. So we look forward to working with you in the future. Thank you.